this review video for systems of equations. Today we're going to review how to solve systems of equations 3 different ways: by graphing, algebraically, and through elimination, applications using elimination. Okay, so what is a system of equation? So a system of linear equations is 2 linear equations on the same graph. So to find the solution to a system of equation, you're really looking for where would the 2 lines cross. So we have 3 options here. We have one solution. So for one solution, you have 2 intersecting lines, and the point at which they cross is the solution. It is the x and y value that make both lines true when we start talking about equations. So we have one solution. We can have no solutions. No solutions occur for parallel lines because parallel lines never cross, so they'll never share a point that would make the equation for 2 linear equations true. Then our final option for solutions is infinite solutions. Infinite solutions are for identical lines. That's where you have 2 lines that lay exactly on top of each other, so they share all of the points. It doesn't matter which point you pick. It's on both lines, which would make both equations true every single choice that you have to make. Okay, so we can solve these by graphing. I want to remind you that when you graph, you need to have your equation in slope-intercept form. So make sure you rearrange your equation if necessary to y equals mx plus b. So we can look at number 4 here to see what I'm talking about. So when I look at the first equation, 2x plus y equals 1. I want to put this in slope-intercept form, so I'm going to subtract the 2x to move it over. And we have y equals negative 2x plus 1. From there, you start with your y-intercept and then graph your slope. Then for our second equation, x minus 2y equals 18. We're still solving for y, so subtract the x to get yourself started. We have negative 2y equals negative x plus 18. Divide each and everything by negative 2. And you're going to get, I ran out of room, so we're going to write it up here. Y equals, this is a 1 right there, so you have a negative 1 over negative 2, so 1/2 x. 18 divided by negative 2 minus 9. So go down to the y-axis at negative 9 and then count up 1, right 2, up 1, right 2. Okay, and where the 2 lines cross, that's your solution. You can see that you could be asked to solve the systems algebraically. You're not given the graph, but you still have to determine the point where the 2 equations cross. And so there's a couple ways to do this. Elimination is one of the easier ways, and what elimination wants you to do is find an x and 2 x's and get them to cancel, or 2 y's. You're eliminating an x or a y. So we always are going to stack these over each other, lining the x's with the x's and the y's with the y's. And I want to have opposites, so either an x or a y will cancel. And so as you can see in this example, there are no opposites to start with. So we have to make opposites using multiplication. When I'm looking at this, there's several ways I can transform an equation to make it so I can have an opposite. But I notice one of my options is if I multiply the top equation by a positive 5, I'll end up with a positive 5y, and my bottom equation has a negative 5y. Those will be opposites from each other. Remember, when you're multiplying an equation, you're going to distribute whatever you're multiplying by through the entire equation. So we will end up with 5x plus 5y equals 20. Okay, now ignore the top equation, and we're going to add these 2 equations together, and by add, we're following the signs. For example, this is a positive 2x and a positive 5x, so we have 7x. This is a negative 5y and a positive 5y. That's what I was going for. I have 0 y's left, so I'm not going to write them down. Then I have my equal sign, and then I have 15 and a positive 20 for a positive 35. We're trying to get x alone, so we divide each by 7, and we get x equals 5. Okay, now that we know x, we're going to select one of the two original equations and plug 5 in for x and then solve for y. I'm going to choose the top equation. We could have chosen the bottom equation. It doesn't matter which one you pick. So I'm going to substitute, instead of x, I'm going to write 5 plus y equals 4. Now we're solving for y, so I'm going to subtract the 5. And y equals negative 1. So what we've done is we found the x and y that make the point where the two lines would cross if we were to graph them. You can always check this by taking the x and the y and plugging them back in. So if I plugged in x and y, 5 minus 1 equals 4. That's true, and you can do the same thing from the bottom equation. For a solution to work, it has to be true for both equations. For our application problems, you'll continue to use elimination to solve these. You'll have to write the equations though. So in this example, Brianna bought 3 bottles of ketchup and 2 bottles of mustard for $11.85, and Logan bought 2 bottles of ketchup and 5 bottles of mustard for $13.73. Find the cost of each. So when you're reading these, you want to have some variables and define them. So I usually go in the order in which they're written in the problem. We have ketchup and we have mustard. So I'm going to say my ketchup is my x value and my mustard is my y value. Okay, that's going to help me when I'm setting it up and when I get it solved at the end. So Brianna bought 3 bottles of ketchup and 2 bottles of mustard for $11.85. So I'm going to say 3 bottles of ketchup plus 2 bottles of mustard, and she spent $11.85. Then we have Logan, who bought 2 bottles of ketchup and 5 bottles of mustard, and Logan spent $13.73. Now I want to know the cost of each. Once they're set up, remember, set them up x's over x's, y's over y's. We're going to use elimination. So I'm looking for things that are opposite in order to eliminate either the x or the y. Now when we're looking, nothing is opposite, so I'm going to have to use multiplication. In this problem, I'm going to have to multiply both equations, unlike the last example where I could make a opposite pretty quickly by just multiplying one equation. At this point, it doesn't matter which variable you eliminate, x or y. I'm going to eliminate the x's, and the way I'm going to do this is I'm going to multiply their entire equations. So this bottom equation has a 2 in front of the x, so I'm going to multiply the top equation by a 2. The top equation has a 3 in front of the x, so I'm going to multiply the bottom equation by 3. But both of these are positive values, and I need to have one of them be opposite so they can cancel out. So I'm going to choose to make the 2 a negative. I could have chosen to make the 3 a negative. I just chose the 2 instead. Now remember, you have to distribute to everything in the equation. We're transforming the entire equation. So negative 2 times 3. So our new equation will be negative 6x. Negative 2 times 2y is negative 4y equals, and then we have negative 2 times $11.85 gives us negative $23.70. Now we're going to do the same thing on the bottom. Remember, you're going to distribute to every term, and we get positive 6x, positive 15y equals positive 4119. Okay, remember our goal, what we're doing is called elimination, so you want to eliminate a variable. My x's are opposite from each other, so I achieve that. They cancel out to 0 and they're gone. Then I have negative 4 plus 15y equals 11y. And we have our equal sign. The negative 23.7 plus 41.19 gives us 17.49. So we're just still solving for y here. Divide by 11 to get y equals 1.59. Now remember, we were talking about cost, so decimals are not surprising here. Now to find the x, I'm going to take the y and I'm going to plug it into either one of these equations. It doesn't matter. I'm going to pick the top one. So we have 3x plus 2y, and now we know y to be 1.59 equals 11.85. Start simplifying. So we have 3x plus 318 equals 11.85. We're solving for x, so we are trying to move everything else away from it. So we're going to subtract 318 from both sides. And we end up with 3x equals 8.67. Divide by 3. And you have x equals 2.89. So to summarize what we've got here, we were solving for, remember, ketchup and mustard. Okay, so this is why you wanted to find your variables at the beginning. The ketchup was the x, so I got to look at the x. The ketchup costs $2.89, and the mustard was the y, so the mustard cost $1.59. Okay, let's move on to inequalities graphing. So graphing a linear inequality is very similar to graphing a line. What you need to remember is if you have an inequality that's not equal to, you're going to have a dotted line. If you have an inequality that does have an equal line with it, you will have a solid line. And an inequality has more than one answer that satisfies the equation, so we're going to shade in an area where all the points in that area will make the equation true. So just like when we are graphing our linear equations, you want to make sure that your equation is y equals mx plus b form. So you'll have to rearrange the equation like you would have to rearrange number 19. We're going to use number 18 as our example though, because it's already solved for us for y, and I want to remind you how to graph. So our y-intercept is -1, so we're going to start where y is -1, and our slope is -3/1. So that's a -3 over a +1. So that says go down 3, 1, 2, 3, right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. If you wanted to have some more points, this was down and right, I can go up and left the same amount to continue my line. 1, 2, 3, left 1. 1, 2, 3, left 1. And that can help us get more points on the graph. That might be helpful. Now, this inequality has no line under it, so it's dotted. Okay, so we're just going to make a dashed line to connect our points. So that means any point on the line would not work as a solution for the inequality, is what that's saying. Our inequality says greater than, so all the y values greater than the line. So to determine greater than, I'm going to go to the y-axis. The y-axis, the y value is -1. Where are the y values greater than -1? If I go down, they're less than -1. If I go up, all these y values are greater than -1, so I want to shade this right-hand side. Any point that's on this side of the line, if you plugged it into the inequality, will make the inequality true, because an inequality has a range of answers that work. All right, so hopefully that was helpful. I will be back in class tomorrow and answer any questions you've got, and I'll see you then.